reckon this is the best room in the building. I'm going to try and stay focused on the talk and not look too much at Big Ben. It's funny, I brought my wife here and she said, the only thing I want to see in London is Big Ben, and it's under construction. So we went over the bridge and we're like, oh, let's go and see London Eye, under maintenance. Good stuff. So let's talk a little bit about mobile development and hope that we can be a bit more successful in this topic than we were in Sightseeing London. So is everyone in here doing Xamarin? A few of you? Has everyone in here seen a bit of Xamarin code? That's excellent. So if you came in here thinking that I'm going to give you this one thing to succeed building your apps, well, there's unfortunately not one thing that will allow you to build the best app and become an app millionaire. But I will try to talk a little bit about some failures that I've experienced when using Xamarin and how we can build apps a bit more successful by applying some principles and practices and see till we can build much better code bases. So before we get into that, my name is Filip Ekberg. I'm a Microsoft MVP, which basically means that I'm not employed by Microsoft. I go around to conferences. I generally do talk on the better side of the things with Microsoft. I don't know if it's because I just turned 30, but I am becoming a little bit more grumpy. Could also be because I've done Xamarin for so long. But yeah, let's blame the age. So I wrote a book called C# Smorgasbord, and I'd like to give everyone here a free copy of the digital version. Just ping me on Twitter if you want a copy, and I'll make sure to send that out after the talk. All right, so let's talk about failing with Xamarin. So I've been doing Xamarin for about 3.5 years now, and I've been looking at this technology since the day they released this. And I've found that I've done projects where I really succeed with using Xamarin, and then I've done other projects where it just utterly fails. So this talk is a little bit of a mixture between how do we apply good code principles and how do we attack our applications to build really successful apps. It's all about the teams, it's about the code bases, and tying all these together. So we'll try and talk a little bit about how we can avoid running into the same pitfalls that I've done and see to it that we build better applications. So, you know, the promise with Xamarin is that we can use our C# developers and just get them to build an app for us. I've been in projects where we've experimented with either just taking developers that know C# and just have them write applications using Xamarin and deploy that to iOS and Android. Now, in theory, that's what should work, and that's probably the cheapest option out there, right? So I've seen many projects fail this way. We hire a lot of C# developers because there's so many .NET developers out there, and then we get an app that's built by a .NET developer that don't really have a lot of experience with mobility and mobile apps. So the other end of the spectrum is that we've tried to hire iOS and Android developers and just have them learn some C#. And that's just as much as a failure as just taking a C# person and teaching them some Xamarin. So you kind of need the mixture of, we need to know a little bit of iOS and Android, we need to know a little bit about C# in order for us to use Xamarin as a toolkit. And it's not just about, you know, the numbers. We don't want to say that we want to share 90 to 100% of our code. We want to make sure that we share the right amount of code in our apps. So using Xamarin is not only about getting the .NET developers capable of building these apps, it's also about educating our teams in how do we share code properly across the different platforms. So how do we really succeed with building one of these applications? Well, kind of the first obvious thing is to build something that's really great. Isn't that kind of obvious? We need to have a good idea for an application. Unless, like, if we have a bad idea, that's not going to work out anyway, so why spend money on that? But given that this is kind of obvious, we need to share the right amount of code in our applications. So I've seen projects where we try to focus on, we need to share all the code, because what happens if BlackBerry is going to release the next big platform and we want to introduce this platform as well? If we try not to focus too much on, we need to share all the code, but think more about share the right amount of code in the apps. And we'll see some patterns that makes it easier for us to share more code, but also patterns that allow us to use the native platforms and build things in the native layers, as well as sharing a little less code and still be successful with the apps. And then we want to make sure that we can minimize the app size. So when you download an app in the App Store or Google Play, you don't want to download a 100 megabyte application if it's only allowing you to do like one thing. So there's tools in Xamarin that allows us to do this. We can apply ahead-of-time compilation. We can use LLVM, and we can use all these things that we have on the native platforms as well. We just need to make sure that we enable these different flags, and we'll take a look at a few examples later on. And then we need to optimize for speed. So that means that, well, if I start up my application, it's built using .NET, which means that it's also going to use Mono, right? So when this application starts, we don't want it to delay too much before we get into the app. So I'm working on an application right now for public transport back in Sweden, where I'm from, and one of our problems is that we have people using phones that are 5, 6 years old. And the other problem is that I'm working with a code base that's almost 3 years old. And it's still using Xamarin. So the problem here is that, well, I'm testing the app using my latest Galaxy phone, and it's everything super quick, starts up in less than a second, and then we get a customer coming in to us showing the app, and it takes 10 to 15 seconds to start the app. And a lot of those things in the app it's bootstrapping Xamarin, we're doing things in the .NET frameworks that's slower on the mobile devices, so we need to think about how do we optimize the apps for all the different platforms. And the promise with Xamarin is that, I bet most of you have seen somewhat of this picture before. We have this platform-specific layer where we have a little bit of code, and then we have a larger layer where we have all the shared logic in the applications. And this here is a great promise, but most of the times what happens is that we end up with something looking like this here. Especially if you have like a product owner that's on an iOS device, means the focus is on building a really great iOS application and an iOS experience. And then I'm not sure why I still have Windows in my examples, because no one builds Windows apps anymore. Unfortunately, I was a Windows user for a long time, but with Xamarin, you have to go over to either iOS or Android, and you need to use a Mac, so you kind of leave that behind. So what happens here is that, well, we focus a lot on building the iOS platforms or the iOS application, and we introduce really nice animations and storyboards and all of that really nice things that makes the app really excellent. But then we get over to Android, and, well, the product owner said, why didn't you just share all the code? Well, because that's not really how it works. So what happens is that we want to leverage Xamarin to share more code without actually making the applications worse. But that kind of brings us into this question, why is it so hard for us to share code? The problem with sharing code is that, well, we go down to the lowest common denominator. In most cases, not really with Xamarin, but if we use React Native or if we use PhoneGap or other tools that allow us to share code, we kind of bring ourselves down to a level where, well, if we have this feature, it's available for all the platforms. So fundamentally, it's hard to share code because these platforms are so different. There's such a big fragmentation between all the different devices that we have on the market. So we have everything from this 80-inch Surface Hub from Microsoft to this little watch here from Apple. And if our code base is going to be targeting all these different platforms and form factors and permutations of devices and Android versions and so forth, we need to think about how do we properly share code across the platforms. And sometimes it's actually okay to build more in the native layer than sharing the code in our applications. So something that I've found is that it's not always about trying for the teams of .NET developers to share all the code, but we need to focus on how do we get the app quicker to market, especially in these days where we try to do continuous deliveries and continuous deployments and testing the app quicker and just getting it out there. If we focus too much on sharing code across all these different platforms, we won't really do anything but sit in our code base and trying to think of ways for us to share code. So when someone brings up all of these different platforms and permutations, I kind of feel like I just want to scream at my monitor. And this is kind of me whenever my product owner tells me to introduce a new feature, because we need to figure out how do we properly share code across the platforms. And one solution to allow us to share more code is to think more of abstractions. And this is kind of obvious. I think if you've been a developer for some time, you've seen interfaces, you've used inversion of control and dependency injections, and you've seen a few different patterns that allow us to abstract more in our code and be more abstract when we define things in the apps or in any code bases for that matter. But one of the things that I've seen happening when we think about bringing things into shared code is that we end up with a situation looking like this here. So we still want to focus on leaving the UI code in the native layers. We have maybe an iOS or Android developer focusing on the interfaces, and then we have .NET developer sitting in the shared code down here. So what happens if I start to write everything in shared code, but I just want to do something slightly different on one of the platforms? That's when you kind of start to leak into these native layers. So your shared code might have, like, if this is running on iOS or if this is compiled for iOS, just run this little small code piece differently. And what I've seen when we do that is the code base tend to get really hard to work with. So I'll show an example later on. It's actually an out-of-the-box example from Xamarin where they tend to do that approach, and I'm kind of against it. So what we want to do here is that we want to have a layer in between here to just make sure that we kind of force ourselves not to leak into the shared code, but we make it possible for us to share more code across the platforms. Because ultimately, what makes an application successful is getting it to market, making it easier for us to add features, and making it easy for us to maintain the app. So I kind of have these 4 different layers that I like to divide my applications into. And actually, these 2 at the bottom here could be the same thing. So let's start from the bottom one here. We can now introduce a .NET standard library, which introduces services and interfaces and abstract classes and kind of common logic across the different platforms. What's really cool here is that previously, if you used the portable class libraries, they were just allowing you to use the capabilities of whatever that portable class library was allowed to use. So in some cases, what happened was that we couldn't do certificate pinning, for instance, in a portable class library. We had to introduce a shared project which just brings in the files during compile time, and that's a horrible development experience because the editor isn't really built for it. Like it's this hack inside Visual Studio that's not really the best. So what happens with the .NET standard libraries is that we can now build things in this library that we couldn't do before, which means that we can share more code. And then we can have shared logic, which is common implementations. Let's say that iOS and Android has one shared implementation for something. We could have that in a shared logic layer, and then higher up, you could have the implementation for Windows. And then I wanted to introduce some shared UI. So has everyone in here heard about Salmon Forms? Yeah, almost everyone. So Salmon Forms is a way for us to, in an abstract way, say that this is how we define the UI. It's now up to Xamarin to figure out how this is rendered on that native platform. Everything is still a native application. It's native components, but we are sharing a little bit more code. So if you asked me maybe 2 years ago, I would never say that you should use Xamarin Forms, but I'll show you a way that you can combine using Xamarin iOS and Xamarin Android together with Xamarin Forms, so you can kind of get the best of both worlds. And then, of course, we have the native layer. So I hear people say all the time that just avoid adding code to your native layers and avoid touching the native projects, do everything in Xamarin Forms. But I think that's not really the best approach. You should do what's right in the native layers and then do what's right in the shared projects. And a way to figure that out is to talk to your teammates. If you have an iOS developer or someone that's experienced with iOS and someone that's experienced with Android, if they just talk to each other and they could come up with a way that's best for both platforms, that's great. So if it's harder to do it in Xamarin Forms, don't do it. Do it in the native projects. But you can still think more about how do we share the common implementations like view models and the logic behind navigation and so forth on the different platforms. So I'm not necessarily saying that more layers is better. I'm just saying that this is a nice approach for us to structure the applications. And most of you have probably heard of a lot of patterns that we can just throw out problems. If you're a Java developer, there's patterns everywhere, more so than in the .NET world, I would say. But we can introduce things like MVVM, and I'll talk more about that later on, and we can introduce dependency injection and inversion of control, just to make it easier for us to build better apps. So why do we want to do this? Why do we want to just throw patterns at the problem? Well, if we take a look at an example coming from one of these Xamarin out-of-the-box examples, is that this one here, it's a splash activity on Android. And my question is, how do we test this? The first question would probably be, why would you test this? Well, if we look at the middle here, there's this section of a little bit of logic, where it's checking, well, if the user is logged in, I want to transition somewhere. And if you're not logged in, show the login screen. Well, obviously, if we, like this little small expression here, it's not really worth testing. But in most cases, what happens is that we tend to then add, later on in the development process, you say, well, if the user is logged in and it's an admin, show this view here. If it's a user that's logged in and it's a super user, show this one, and so forth. Then it tends to grow, right? And you tend to have the same logic across all the different platforms. Because most of the apps that we build are the same on all the different platforms. It's just different code. So what we want to do here is kind of think of a way that we can break this out. We want to decouple the applications, which means that we want to pull those pieces out that are common across the different platforms. If we think more about this as an abstract way, we can define this as something called a view model. So what I have here is a way for us to define that we have something called settings. We can check if the user is logged in, and if they're logged in, we can do something depending on that. And this here is not really depending on the platform itself. We could have the implementation for iSettings on Android and iOS, and then we could handle the navigation or listening for an event happening on the native platforms. This way, we can now test this view model if we wanted to, and we have the same logic for both of the different platforms. Does anyone not think this is a better approach? Good, so everyone agrees with me. So what about the platform-specific code? If we want to do something very specific for one platform, how do we do that if we're bringing everything out to these shared layers? Think about NFC, for instance. I don't know if you heard, but about 6 months ago, Apple finally allowed you to interact with the NFC chip on iOS devices. But it's only one way, so you can only tap your phone to something, and the phone can detect, if you have the app open, it can detect whatever tag you tap on. On Android, you can do both ways. So you can say, tap on something, and it can both read and write to that particular system. So they kind of did it half right on iOS, which means that if we introduce some features that use NFC on our applications, we'd have to do it a little bit differently on the different platforms. You could argue that you say, well, if it's running on iOS, just disable everything that has to do with NFC. If it's Android, you're allowed to do everything. And one approach to solve the platform-specific code is to, of course, introduce compiler directives. So in this example here, we have shared code, but it's going to be a little bit specific for a particular platform. So this method here is simply going to get some content out of an HTTP response message. The message itself is using deflate or gzip, so we need to decompress that in order for us to read the content on the platforms. And unfortunately, on Android, that's not happening out of the box. So we're saying here that, well, if this code runs on Android, we need to decompress the message first. If it's running on any other platform, it just works out of the box with using the stream reader. Now, I mentioned earlier that I don't really like this approach here. And a better approach would probably be to inject the way that we do this on that particular platform. We could say that we have an ID compressor or an iDeflate interface that's implemented by that particular platform, which is probably a little bit more testable. And a way that we can do that is by introducing something like tiny IOC into our applications. There are other IOC containers like AutoFac and a bunch of other ones out there. But this one works really well. You bring in one file into your project, and you have all the capabilities that you need from an IOC container. So what happens here is that we register something called an account service, and we map that to this implementation. We have an iPreference service and map that to this implementation, and iCache, map that to this implementation and say that this is a singleton. So whenever you ask for a cache, you just get one. And what's interesting here is that if you ask the container to give you an iAccount service, if the iAccount service depends on the preference service, meaning that if the constructor of our account service wants an iPreference service, it's going to automatically create an instance of that and inject that into the constructor. So if we think about this in the broader sense, we could have an ID compressor in here and inject that into our HTTP handler or whatever we use on the platforms. So this means that we can register implementations on the native platforms for things like NFC and for things like checking flight mode and so forth. So someone once told me that you should just interface all the things because that makes everything a lot more testable. And then you start to work with Android, and there's no way to actually inject anything into a constructor, so you have to rely on something called the service locator pattern. The service locator pattern is kind of an anti-pattern, which means that it's not really the best thing. So the way that this works is that we're saying we have this class which knows about all the different services in our solution, and it simply uses our container to resolve that implementation. So let's have a look at a little bit of code that's using the service locator pattern. Is anyone in here using Rider? Yeah, a few of you using Rider? So obviously you still need to have access to a Mac to work with Xamarin. They've done a lot of improvements in the way that you can now use like a Windows machine on a different network, and it can remotely compile your iOS code on a Mac, but you still need to have access to a Mac. And the fact that I think all the development is a lot quicker using a Mac, I've swapped over to Rider because I think it's really great. So Rider is built by JetBrains, which means that it has all the ReSharper shortcuts, and I can do all my refactoring, and I think it's great. And I don't work for JetBrains either, I just like the IDE. So what I have here is that I have this solution with my first demo project here. It's giving us an iOS and Android project. I have a shared project up here. I mentioned earlier that I'm kind of allergic to these shared projects, but they still come with the demo solutions that you create using Xamarin. And what we get in here is a way for us to define the application. So what we can see here is that they're actually using this. If it's iOS, run this code here, which is that the iMessage dialog is going to be an iOS message dialog if it's compiled for iOS, and it's going to be this here if it's running for Android. I would argue that you could probably move these two lines over to the platform-specific projects. Would make a lot more sense, because then we could take this shared code or shared project and convert that to a .NET Standard project instead, and have it available on NuGet, which means that we can share the code with our backends as well if we wanted to do that. So I think that in general is a better approach. So here we can see that we're registering something with something called a service locator. It's grabbing the instance of our service locator and saying, well, for an iAccount service, I'm going to register this implementation, which doesn't matter what it's doing, but it's going to introduce that. And then, of course, inside our Splash activity, for instance, we could, at the bottom here, after we do this code here that I argued we should move over to a view model, we can then say, well, I'm going to save something into my account service, which I can then, of course, use inside my application. So I'm just going to run this here and show you what it looks like. It's nothing fancy, but it's a starting point for the other demos that I'm going to show you later that's showing some better patterns and practices. So the problem with this here is that it's asking for a dependency inside a method, and if I'm writing a test for this part of the code here, it's really hard for me to know which dependencies is it relying on. It's hard for me to mock the data it's using. It's hard for me to know anything, really. So let's see here if this is so you see here it says sign in as Filip here. So it went through the Splash. It went into this login view here, which we could probably see in the Android project. So we probably have an activity here called the login activity. We can see here that it's saying get the iAccount service. Sign in button's text should be sign in as the account name. So it's using that here as well. And then this is just a simple Android application. It's super quick. It's native. It's using Xamarin. It's sharing a little bit of code with the iOS project. The iOS app looks pretty much the same. I'm not going to bother showing that. But what happens is that if we look at the code that we have in here, there's a lot of folders with all these activities and assets and fragments and whatnot, which is all Android specific. And the same goes for iOS. We have view controllers and helpers and so forth that allows us to build the UI for iOS. And then what they've done here in this shared project is that they've introduced view models, but they haven't done it for everything in the project. I would still argue that you would have a Splash view model here. But they've tried to do that, for instance, for the login view, which then allows us to say things like, this is shared logic. The title for the login page is going to be login no matter which platform you're running this code on. So even if we're not using Xamarin Forms and we're using this shared project approach, we can still use a view model. We can still use commands, which we could set or handle on those different platforms. So we can still try to apply these different patterns no matter the platforms. So that's a starting point for the demos that I'm going to talk more about later on. But we kind of saw here that we have this idea of a way for us to retrieve dependencies in the projects. I can ask for an iAccount service in wherever in my code, but I'm not really in control of what's injected into the method. A better approach would be to say, well, this method depends on an iAccount service, but since there's no kind of native support for that, it's really hard to build something like that. And I've been in projects where this kind of grows out of proportions. In this case here, it's a very small piece of code. It's very, it's just this small demo, but I felt so many times that I'm like, damn, what have I done with my project? Using the service locator everywhere, all the code is really hard to test. It ends up being this mess of spaghetti code, which means that it's really hard to maintain, especially with code bases that are 2, 3 years old. I don't know if anyone in here is using or working in a project that's 5, 10, 15 years old, but once the few of you are actually working with older projects, so you probably know what I'm talking about. Like if you end up with a really bad situation from the start, it's really hard to rescue that project without just throwing it out and rewriting all the code. So one way that I want to kind of fix this and make it a little bit better is to add something else to the project that hasn't really worked out that very well in the past. I'd argue that Xamarin Forms has been this thing that I know both Microsoft and Xamarin, before the acquisition of Xamarin, really wanted to work out, but I think it's at that point right now where it's starting to be really good. So what we can do is we can add Xamarin Forms to the mix, which means that for new views and for new controls inside the app, we can say, this here is going to be pretty much the same on all the different platforms. Imagine a login view or an about page or something in the app that's kind of generic. It's not really the core function of the app. We could introduce a shared UI. And it's still going to render as the native platform or the native components, but it's shared. You use an abstract way to define what the UI looks like. And Facebook is doing this approach inside the Facebook app, so they're heavily focused on, they're not using Xamarin Forms, by the way. They're using something totally different. So what they're doing is that they're heavily focused on performance in the app. So the app is probably written in C++, but then they have this nested page like 5 levels down that's built in React Native. So because it looks the same on iOS and Android and no one really goes to that page, so those people that do, they don't really have to worry too much about spending too much time building that page. So that kind of, the same thing applies here. So if we're working on an application, it's not really performance heavy or there's not a lot of graphical things that we need to do, we could introduce Xamarin Forms and hopefully we'll eat up all this shared code that leaks into the shared code, and we can have our .NET standard product down here. We can have a little bit of shared UI code or a lot of shared UI code, depending on the project. And then we can have the platform-specific layers, which still allows us to be really great on that particular platform. So how do we do this? Well, we can use something called Xamarin Forms Embedding, which was introduced or is introduced in, I think it's the next version of Xamarin, but it's been in preview for about 6 months. So here I have this thing called the main page, which is a Xamarin Forms page. And now I can simply say, give me a fragment of this view here, or give me a view controller on iOS, which means that we can combine, for instance, an activity to say, well, this up here is actually the native activity, and this part in the middle here is using Xamarin Forms Embedding. So I can combine these different paradigms and these different ways to create my UI, and I don't have to choose, do I want to go with Xamarin iOS and Android, or do I want to go with Xamarin Forms? I can combine them as I go on. And they've just announced as well, speaking of something totally different, that if you're working on an iOS and Android project and you're using Swift or Kotlin, you can in fact reference .NET DLLs using Xamarin as well. So you don't even have to use Xamarin anymore as a total project, which I think is pretty cool. I think it's the way to go to provide us with options in a way for us to share the right amount of code in our applications. And of course, we can do the same thing for iOS. We can say, give us the main page here and create a view controller, and we could add that to a navigation view controller or a tab view controller, and this would render, I wouldn't say nicely, but it would render on our iOS device here. But what's cool here, if we have a look at the code, is that this Xamarin Forms embedding allows us to define the UI in kind of an abstract way for a particular platform, or for all the different platforms, actually. So the same project, I have a shared, I'm going to close all these other tabs. So what we have here is that I simply have this code here saying, create my page. I've got a button that you can click. It's going to be centered in the middle. When you click that, it just updates the text. Super simple. And then I can use this page in both iOS and Android. So let's have a look at one of the activities. Let's go to the main activity. I'm going to zoom this in here. And we can see here at the bottom, so this here is using a tabs adapter, which is a way for us to create a tab controller. You can click 2 tabs in Android. And one of the tabs is going to be a Xamarin Forms page. So you have to call Xamarin Forms init and then create fragment. And that's allowing you to just embed this as you would inside Xamarin for Android. And I think this is a good approach. So if we run this here, and of course we can have a look at the iOS code as well, just to give you an idea that, well, if we change anything in here, we have this shared UI that's living inside our Xamarin Forms UI project. It's totally separate. It's compiled separate. And I think that's great. And this is just like the first building blocks on the madness that we can achieve by introducing a shared UI project. Because if we introduce Xamarin Forms, that allows us to use other components inside Xamarin Forms. And we'll talk a little bit about the messaging center, which is an event aggregator. We'll talk about how we can use the dependency services to inject dependencies automatically. And we'll talk about Prism and how we can use MVVM extensively in the applications. So I'm clicking Not Now here. And hopefully the About page here is going to say Click Me. So this is Xamarin Forms. It's showing up here. And one of the problems that I've found, so we were pretty early on using this in the app that I'm working on now. And on iOS, this works really well out of the box. It's really performant. Like you can't even notice that you're using Xamarin Forms. But even on newer Android phones, this tends to be a little bit slower. Like startup times and loading-wise, it's a little bit slower and laggish. But once it's loaded, it's super snappy and it's super quick and it's really great. And I think I would argue that the way that I can share the UI and like the benefits kind of overrules what I have to pay in performance the first time you start the app. So let's have a look at the iOS app as well. So if we look at the code, we have the iOS project, I have a view controller, I have a tab bar view controller here, which is what handles the tabs on iOS. There's a little bit more code here because I want it to look a little bit nicer. I'm initializing Xamarin Forms. I'm creating my page here inside a navigation page to get the nice navigation bar at the top. I'm setting a few colors. I'm creating my view controller here with Xamarin Forms, and then I'm just setting the view controllers on my tab controller. So the code isn't really important. It's less code here than I'd have to write in my iOS project to achieve the same thing. And I think it's pretty cool that you don't have to spend too much time working on all the code for the different platforms. You can build this in one place, and once you have that in place, it's easier to test and easier to change. Of course, the problem with Xamarin Forms is if you want small differences on one platform that's not supported by Xamarin Forms, you have to introduce custom renderers, and that's when it becomes really expensive. So this is the app for iOS. I'm not sure you knew this, but the new emulators, you can resize them. Just a side note. Click Not Now here. I'm going to click About here at the bottom, and we have the same thing here, which is Click Me, and we have the same code for the different platforms. Notice at the top here, I couldn't get the tint color right. I'm not sure the projector is showing this correctly, but it's a little bit more blue on the About page. It's because I'm choosing that inside Xamarin Forms. So graphic-wise, it might be a little bit harder to get it exactly as you would if you do that with a storyboard or a nib file, or if you did that code behind on the iOS project. But again, I think the benefits are really great. So Xamarin Forms Embedding allows us to start sharing more code that's common across the platforms. And this kind of brings us into the next thing, which allows us to do something called dependency injection and do this a little bit more proper, I would say. So with Xamarin Forms, we get this way of defining an assembly or defining a dependency on the assembly level to say, well, here's a dependency for the account service. And then it understands that, well, this is the account service here. It's implementing the iAccount service, which then means that we can get this dependency by saying get the iAccount service. And that would work anywhere inside the app. Still, it looks like an anti-pattern, but if you use this properly, it'll still be a lot better. And when we introduce Prism, it's just going to, hopefully, it's going to open your eyes to how we can do this really nicely and share more code. So this, together with something called the messaging center, which is a way for us to communicate between the native layer and our Xamarin Forms layer, is a great way for us to make sure that if I click the login button and I want to navigate somewhere, I could listen for something inside my activity to say, well, when you click the button here, I want you to transition somewhere. Right? So it's kind of like an event aggregator. And it's not only for talking between activities and things inside Xamarin Forms. You can also talk across different view models and so forth. And the way that we use this is it's pretty simple. We subscribe to a message from a particular view model to say, well, when login completed is fired from a login view model, I want to run this code here. So I want to transition somewhere inside the Android app. And then we simply say, well, inside our view model, we'd simply say, well, send this message for the login completed. And then it sends the view model itself as well, so we could grab all the data that the user entered inside that, for instance, that text field. When they click the button, we can get that inside our native layer. So let's have a look at that, because this is where it starts to get interesting. And this is where you start to share more code, and hopefully it'll be a lot better. So kind of the same application I've just added to the project. But in this case here, there's a little bit more code inside our demo3.ui project. So we'll see here that I have a view model called a login view model. And we can see here that what we're doing is that I'm defining a property called username. I have a command. These are triggered from my view itself. So when you enter your username and click login, that will fill in the username text field here. When you click the login button, it will run whatever command you have in here. And that command is, in fact, grabbing our account service, saving some data into the account service, and then it's distributing a message using the messaging center. And I'm using just a local version of the messaging center because at the time I wrote the demos, the messaging center was broken for some reason, which isn't that rare when you work with Xamarin. So fun story, we've actually had to bring down the Xamarin Android project and hotfix some code in the Xamarin tool chain and deploy that to our build service because something broke in Xamarin. That's a bit annoying, and that's one of the problems when you choose to add another layer of abstraction between you and the native platform. Even though the app is native, there's still this tool chain between you and getting that app that could break. Anyways, so this here sends over a message from the login view model, embedding the view model, and whoever listens for the login completed command or the login completed message will retrieve this here. So what happens is that inside our Android project, I've set this up for one of my activities. I have a login fragment activity, and we'll have a look at this code here. And this here is saying, well, initialize Xamarin Forms, listen for a message. So we subscribe for a message from the login view model. Whenever login completed is fired, we get the view model, which is called object here, and then we run some code. And so this just sits here and listens, and then it just shows our login fragment down here. So I'm going to put a breakpoint in here, and I'm going to run this with the debugger, and we'll see if we get that view model in here. So again, this is where it starts to get a little bit interesting, because now we can write more code that's shared inside a view model, and we can do more logic. If you click the login button and it's empty, do something. If it's the admin username, give them admin privileges and so forth. You can do a lot of cool and crazy things. So I'm going to click sign in here, and this will allow me to write my name. I click login. And you'll see here that, I'm not sure you can see that at the bottom here, but it says Filip here at the bottom, which is the username. So we're now inside the activity. We got the object here, and that's our view model that was passed from the view model itself. We're inside a message that was distributed from Xamarin Forms. We were listening for that inside our native layer, and then we transition into the app, and if I click About here, it's going to say Filip here at the bottom, and this here is another Xamarin Forms page. So we've kind of totally decoupled functionality in the app, and we can get the same experience if we run this on iOS and Android, which is kind of the benefit of using Xamarin, right? If you share the right amount of code, like I don't have to share the code that tells me how I create a new view. Like I don't have to share the code that says this is how you navigate. I can still listen for this message, but this here lowers the amount of code and the amount of problems that I can have when I touch my native projects. But it's still okay for me to write code in the native layers. So one thing that I find is people tend to be scared of adding things or adding too many things to the native layers when they're using Xamarin Forms. So I think that's pretty cool. And the same would, of course, apply for iOS as well. All right, so I have 2 more demos. I'm going to first talk a little bit about MVVM. Is everyone familiar with the MVVM pattern? Great, so not everyone knows the MVVM pattern. It's a way for us to kind of split up even more inside our application. So we have something called the model, which is the M, that represents the data that we could get from either the database or an HTTP call. And then we have the view that represents how is this all presented on our screen. And then we have the last part, which is the view model, which says this is how you display things, or this is what happens when you click a button. For instance, you might have a text field that's going to represent your username, and the view model knows how to kind of append your full name together. If you have 2 fields in the model that's saying first name and last name, the view model might add those 2 together to give you a full name. Does that make sense? Good. And then you have a way for you to handle what happens when I click a button and so forth. And inside an MVVM framework like Prism or MVVM Cross, or there's a bunch of different MVVM frameworks out there, you get things like navigation. You can say, I want to go to this view here, I want to show a model view dialog, or I want to navigate somewhere. You can have event aggregation, which is the messaging center that I talked about, and then you get dependency injection. So all of these things together allows us to build more loosely coupled applications, and they allow us to build, hopefully, better code bases. So I like to show code instead of just talking, so let's do that instead. Kind of the same code base. I've just added a little bit more. So inside in this case, we're inside the Xamarin Forms project. What I'm doing in here is that I have my app.xaml.cs, which is a way for me to define the application. And here I'm saying this is a Prism application. And a Prism application just means that they handle a lot of cool things behind the scenes for us. They do dependency injection and so forth. Internally, Prism uses something called Autofac, which is another IOC container, which allows us to register dependencies and so forth inside Prism itself. So what I'm doing here is that I'm saying, well, I want to define a few dependencies. And what I'm doing here is that I'm saying, this is a mouthful, but I'm saying, register an instance. Get the instance from the dependency service, which is using Xamarin Forms. We're going to get an instance for the iAccount service, and we're going to register that instance within Prism itself. That just means that now Prism knows how to act whenever it sees an iAccount service. And just to show you what I mean is that I have a view model in here called a login view model. The login view model has a constructor that takes an iAccount service. So when I create an instance of the login view model, I need to know about the account service. But I don't want to create this myself. So what I'm doing is that inside my view, I have a login view here, which simply says I have a username, a login command, it's binding that to my view model. So this field here is bound to whatever I have in my view model. And I'm telling Prism to just automatically wire up the view model for me. And that means that it's going to create the instance. It's going to create an instance or get the instance for our iAccount service, inject that into our view model, and it'll just solve all these things magically for us. So a way for us to just illustrate that is to have a breakpoint in here, and then have a look at how we initialize this from Android. So I have this activity called the login fragment activity that we saw earlier. And what I'm doing in here is that we simply say, create a new login view. That's going to create this thing here. It's just going to do a new login view, and then create a fragment out of that. I don't set the view model. I don't do
anything at all in there, it's all handled by Prism. So I'm going to run this here with the debugger attached. And hopefully this works. It's going to build the application first and then ask me where I want to deploy this. It's installing that into my emulator. And now hopefully when I go to this view here and click login, it's going to trigger that login view model breakpoint that I had, because that's when it's supposed to create that for us. So I'm going to click sign in here. That's going to go to our login view. And this here triggers our login view model. So that was created by Prism for us. So it injects our account service. We can see here that it gets this instance here at the left, and then it's setting everything up for us. And then I can log in as Filip again, click login, and everything works as it did before. But in this case here, what happened is that I don't have to care about how do I create the view model. I can say, well, this view model depends on this interface here. And that means that I can now say, write a test for this code here that injects a mocked version of iAccount service, which means that I don't have to specify exactly the same account service. And this is really important if you're writing a lot of tests, unit tests, for instance. If you do integration tests, of course you want to test the entire application, but it's really helpful if you want to increase the quality of your code and the quality of your tests. So this kind of puts us in a really great spot, because now we can write more code in here that's shared across the platforms. I could say that, well, I have the iAccount service, and that works in one way on iOS and a different way on Android. That means that I still have shared code, but I can still go to the native layers and introduce things that aren't shared. So this here kind of means that the code is more testable, and it's more maintainable, and I generally say that it's more fun to work with because I like to use products and things that help me be more productive, and I think Prism is one of those things that do that. And the fact that I don't have to just create a new project and use Xamarin Forms for everything means that I can choose small pieces in the app that I want to make better, and then we can start to phase out older parts of the application. Okay, so one final demo that I want to talk about is ahead-of-time compilation on Android. So one of the things that we found with the Android applications is that they use just-in-time compilation. With Xamarin, they deploy all the .NET assemblies inside your package binary. That means that when you run the app the first time, it needs to compile for that particular platform. And that's not always the best case, because that means that on older phones, that's going to take a lot longer to run the app, and we're going to have unhappy customers telling us that we're doing a bad job. Now, as I said, I work in public transport, so people blame me for the buses being late anyway, so I'm used to taking a lot of bad criticism. So what happens is that I want to tell my Android application to just compile everything to native code. But before we turn on those flags, I'm going to show you here with the first project. We're going to set this to release mode, and we're going to do release x86 for the first Android project. I'm going to build and package this here. First, it builds everything for us. It builds all the .NET DLLs. And then what happens is that I can package my application to say, well, now I want to create the package that we deploy to Google Play. It does take a little bit of time to do that, but it takes a little bit longer when you turn on the flags for ahead-of-time compilation, but it's totally worth it. Especially if you only do this when you're deploying the applications. So if you're using Writer, you go into Advanced Build Actions, you do Package Selective Projects. It'll take a little bit of time, but we can go ahead and check. Reveal that in Finder. I'm going to go into the binary folder, release. It should display an APK up here as soon as it's packaged. You'll notice because one of the top things there will be very much larger than 10 megabytes. It's kind of interesting, right? Because we see here that, well, mono Android is 10 megabytes, which is kind of a lot for just bundled with an app. So now it introduced this APK file here. It's 21 megabytes. I'm going to rename this. Did you know that an APK is just a simple zip file? You can say use zip. We can unzip this. Has anyone deployed a Xamarin application to Google Play? A few of you? did you know that all your assemblies are available, inside the apps? So we have all the assemblies here. It bundles everything that we have in our applications. We can see that we have my demo1.droid.dll. So if I bring that down to my computer, I could inspect all the code. If you've tried Reflector or any other tools like that before, it allows us to just browse the code pretty much the same way that we wrote that in our environment. So I noticed this when we were talking about how do we obfuscate the code in our applications. I was looking up all these different obfuscation options, which is a way for you to kind of hide all your logic. It's a way to be, you put your hat on, you're like, I'm afraid of everyone stealing my logic. So what we notice is that, well, it bundles all the .NET DLLs. There must be a way for us to say, well, I just want to compile everything to whatever native code there is. There's a folder here called lib, which includes all the different platforms and all the code for those different platforms. So for instance, we have the code for x86, and all that's available in here is the native code for Mono. So I want to grab all my code, and I want to somehow bundle that into the native code and get rid of all those .NET assemblies. And the way that we do that is by simply changing a few things in our project. So I'm going to edit my CS proj, and I don't know these by hand, so I'll explain them. The first one is going to say, well, I don't want to use a shared runtime because you always want to turn off the shared runtime for your production applications. We're going to turn on multi-dex, which is a way for us to allow us to write applications that are a little bit bigger, use a little bit more references in the app. Especially if you're using .NET Standard, it's going to bring in a whole lot of dependencies. If you don't have multi-dex on, you'll have problems compiling the app. It also allows you to turn on things like ProGuard, which is a way for you to protect your code. Anyways, you also want to turn on packaging of the application, so I don't have to do the packaging myself. So I'm going to put that up here in the first property group. And then there's one more thing that I need to add. There's a little bit of more code here. It's going to say that we want to link all the SDKs. It's going to say that we want to embed all our assemblies into the APK. It's going to do an ahead-of-time compilation, which basically means everything is going to be native code. And then there's a few other options as well that allows us to be even more strict, to say no debug symbols, remove everything that has to do with the debug, and again, turn on multi-dex for that build. So I'm going to copy all of that code, and if you're interested, I can just give you this later on. I'm going to put that down here in the release part. And then we're going to build the app. And you'll notice that what happens is that it's going to take a little bit longer because it's going to do, I'm going to zoom in a little bit here, because it's going to link everything. Then it's going to say that it's going to do a full ahead-of-time compilation, which means that all the assemblies that I bring in from Microsoft and .NET Standard and so forth, it's going to compile that into native code as well. So this process is going to take a little bit longer, maybe a few seconds longer with this kind of solution. And remember, this is a very small solution, right? So if we have a larger project, it'll take a little bit longer than this. We had a problem with our build server. I think we ended up having builds taking 80, 90 minutes, which is a long time to wait for an app to build, which is something that we hadn't noticed when using native development before. So one of the other interesting things with Xamarin is that even you can write the best code in the world, but finding the right people to do this is really hard. So one of the things that we found in the project, while this is building, I'll tell you a little story, it's really hard for us to find people that know C# as well as know all the small things and gotchas about the different platforms. So we have iOS and Android developers that are really good at building apps for the native platforms. And we have .NET developers that know everything about the .NET framework, but finding the Xamarin people is really hard. So sometimes the way to be successful with Xamarin is just not to use it. I'm just joking. All right, so we see here that we have the APK. It is a little bit larger than we had before. Which is because it had to compile everything into the app. It had to link everything. It had to make everything native code. So I'm going to, this time I'm going to rename the signed version to the zip, and I can't use the built-in zip tooling for that, so I'll just use another app. Extract that the same way I did before, and you'll notice that there's no longer an assemblies folder. So all the assemblies are gone. I have this library folder here which now shows us all the different assemblies for the app. And you might see that it says libaot there. It's ahead of time compiled. All of these are called .so files, which is the natively compiled binaries. So with iOS, we always get this out of the box because it's natively compiled. They don't have a just-in-time compilation. It's good to have just-in-time compilation on Android because that means that it can be a little bit faster in general for the apps or for the platforms. But when you turn this on, it's going to drastically improve startup times, which is one of the most annoying things with applications that take a long time to start. So this here is probably going to make your users a lot happier. Okay? And you don't have to pay thousands of dollars for obfuscation because it's really hard to read the native code. I asked someone at Xamarin if you can compare this process here to obfuscation. He said, well, it's really a poor man's obfuscation because it's not rewriting any symbols, it's not doing anything weird. It's still the same assembly, right? So it would look the same if you look at the native layer, but reading this as C# code is pretty much impossible. So at least we can be happy about that. So when you tie all these things together, you talk about the way that we can share the right amount of code. We talk about finding the right people and enabling things like ahead-of-time compilation. That's when Xamarin starts to feel really great. Because that's when you can build apps faster, the apps are really working as intended, and they work really good on those different platforms. So hopefully you end up with a situation looking a little bit more like this here. It's still okay that one of the platforms has a little bit more code than the others. You might have someone working or loving iOS more, so they spend a little bit more time just fine-tuning the iOS UI. And then you have someone that doesn't really care about Android, but he's still doing the Android app, right? So this way here, we can see that we can still work a little bit in the native layers. It doesn't really matter. Just try and share as much code as possible using these different principles. So how do we succeed with the app? Well, it's obvious that we need to build something great. We need to have a good idea of what we're building, and we need to have a customer base that wants the app. And we need to share the right amount of code, which means that we need to apply patterns that makes this easier for us. We want to try to avoid things like the service locator and the compiler directives because that's a way for us to kind of run into a messy piece of the code. And we want to minimize the app size. In the demo I just showed you, we kind of doubled the size. But we can turn things on like optimize PNGs on iOS, which lowers all the file sizes of images, which is one of the biggest culprits of our applications. And I think that Google Play and iOS and app stores, they do their best in minimizing the app when they're delivered to the phone, so don't worry too much about the APK size. And of course, we want to optimize for speed as well. So just to wrap this up, there's a lot of things that we can do with Xamarin. It's a great toolkit if you find the right people to do the job. And sharing the right amount of code is really hard, but one of the easiest ways to share a lot of code is to talk to each other in the teams and make sure that you understand what you're building for those particular platforms. Before you leave here, I want you to leave a green thing in the box. Hit me up on Twitter if you want a free book. All right, thank you so much. I'm Filip Ekberg.